So the next set of slides comes from Netflix itself, with Xavier Amatrian, who is the personalization science and engineering. You see the field of study that is relevant here. And this was a tutorial I gave in 2012 at a Recommender Systems conference. And it basically describes some of the issues Netflix faces in building recommender systems. Because in some sense, the success or failure of Netflix as a company is going to stand or fall on their recommender system. Note that Netflix is not an infrastructure company because it hosts its infrastructure on Amazon, and so its success is based on the software it uses to manage the infrastructure it buys from Amazon, and how those a key part of that management is taking care of the users and giving them a very great experience. So, as it says here, everything in Netflix is a recommendation, and also everything is personalized. There is a question that's raised later as to whether the person, which has been commented on more than one place, which is whether a recommendation is for a user or for a household, because if Netflix, which is essentially watching movies, it will be on a device as it's shared by many users. So Netflix is actually not recommending things for one user, but for many users. Possibly there's some technology called latent factor analysis, which might be able to discover there are multiple users by noticing that the likings of this particular household are not sort of very uniform, but indeed they group into, say, if there were 3 people in the household, into 3 different subsets, which are rather distinct from each other. Anyway, everything is personalized, and you can have rankings which are ranked by how likely that particular movie is to satisfy you. So that's from left to right, or from top to bottom. You might get different rankings done under different criteria, which we'll discuss. So here it points out actually that the criterion that uses is in recommender systems. Here it says top 10 recommendation is to make certain they're diverse. So that if there is a household, we don't choose all of dad's desires, but also include one for daughter and mom and son and things like that. So that's done by ensuring that the recommended items are diversely spread across the possible space of answers. So we won't actually discuss how to do that, but it's relatively clear that if you have a space and you have points in it which you think are the points that people might be interested in, there's obviously that you could make certain that when you rank the top 10, you make certain that top 10 are not all focused in one small region of that space, but are spread about the space. I noted earlier that thinking of these this problem as points in a space, and here we're thinking about movies in a space, and then is a useful thing to do. So here it tells you how it generates the different rows, and you can move the different personalized rows to the top to keep people's attention. And we have implicit rankings. Those come from just seeing what the person chose and using these so-called things like collaborative filtering to suggest other movies which you expect the user to like, because usually because the user's community, his or her community, like those movies. Another possibility is more the explicit taste. that the user has specified that, I don't know, they like science fiction, and so you would then give them rankings within the science fiction category. Of course, everything, as I said, can be hybrid, and we pointed out these other criteria. We don't keep making the same recommendation if the user hasn't taken it. Maybe he or she is trying to tell you something, doesn't like that movie. And we pointed out the importance of diversity. Um, so this just gives an example of suggestions given by Netflix. So this just summarizes what we've said, that everything is a recommendation, and we have rankings, and we select different rows, different criteria, and so on. And the user it has to be automatic as much as possible, but the user can be involved, and it's good to make the user involved, because then you can put the user's explicit preferences into what you present the user. And we've already pointed out the importance of diversity, of freshness, and maybe even to explain recommendations. One of the difficult features of so-called machine learning, which this is an example of, is you have a magical method, which is, say, collaborative filtering, which gives you some results. But often it's not quite obvious why those are the right results, and maybe to explain to the potential movie watcher why you made those suggestions is a helpful thing to do. Here's some data about Netflix updated to April 2013, at which time Netflix had a current total of 29 million subscribers, and it added 2 million subscribers in the previous 2 quarters, the previous 2-3 month segments. And you can see some data for the this is for fall of 2012, that there are users are making 4 million ratings every day. One of the interesting features about all these fields is the users are helping the companies, because these ratings are what the companies use to make recommendations. And instead of sitting there scratching your head waiting to find data, the previous users are supplying the companies with this wealth of data, 4 million ratings of movies every day. This is something that never used to happen. We never had this type of data. And then we have actually somewhat fewer searches, 3 million a day, and the number of movies played is 30 million a day, with 2 billion hours streamed in the last quarter of 2011, and that's already increased in 1 month of summer 2012 to 1 billion hours in a month. Pretty impressive, and this is an example of today's technology companies. Here we have some fancy names for the technology. Regression, these are elastic nets, these are all approaches to machine learning. And we've a lot of things are done with matrices. We have clustering, which allows you to find which things are near each other. We have association rules and decision trees, which give you a hierarchical way of building up relationships between things. And latent Dirichlet allocation is a very famous technology invented by a brilliant young scientist, which is used for finding hidden information. And you have a collection of data, which is like documents or movies, and it will effectively group them together according to so-called latent factors. So latent factors are things which are not obvious, but can be determined based on other characteristics of the item. For the that could be the rankings of users. In the case of documents, it's often the words in a document. It could be the words in a movie, and you can then group movies together based on these this sort of rather blatant data about their makeup, and then you can use the um, you can try to identify what's near each other based on that, and that's what LDA does. And there are many related technologies such as semantic indexing and things like that. So there is a very famous $1 million prize given by Netflix to try to improve their rating prediction. And this comes from this website, Kaggle. I think I don't know whether this, but I doubt if this came from. It might have come from the Kaggle website, but and this just shows that in this particular um, prize was given in September 10th, 2009. And this had an intermediate stage. The prize went in 2 stages, where the first stage was by a team from AT&T, which improved the algorithm by 8.4%. And they actually had an incredibly complicated algorithm with 107 different algorithms combined together, because I pointed out hybrid methods. So there are many different ways of deciding how to predict which movies people will want, and none of them is terribly good, but maybe 107 of them are pretty good, and that's what this team exploited. And here is the final prize with the 2000. This is September 2009. Check for $1 million with the team that won the prize. Here's a nice comment on this general area of from this. I think I mentioned this slide earlier in the class, from the senior vice president at Walmart Global E-commerce, and he's pointed out that he taught a class, and as part of that class, he discussed rating of movies, and then he had many teams in his class, and he pointed out that some teams did what actually the winning team did, namely really improve the algorithm. But another team say, hey, there's some more data out there we're not using. And the team that did better in this Rajaраman's class was actually not the team that had the fancy algorithm and lots of mathematics. It was the team that added more data. So this is why this slide is called more data usually beats better algorithms. And that's why we talk about data mining in the fourth paradigm. Data can tell you things which are quite unexpected and can be done independent of any theoretical study. Here's some more precise statements about the recommender systems from Netflix. The ranking involves scoring and sorting and filtering a bag of movies to present that to the user, and you want to find the best possible ordering of the videos within a specific context, and this has to be done in real time. When you're shopping on Amazon or in fact on Netflix, you're not going to wait for the recommending to happen. You need to be able to know now what to buy, and so there are many actual algorithms, some of which are quite time-consuming, and those algorithms still have value. They can be used to prepare the data for the later use online in real time, but the actual recommender system that's used while the user is online has to run in fractions of a second so that you can present the results to the user immediately.